Hello and welcome to Young Minds versus Physics. Yes, in the last video, we ended up the class by leaving three problems to you. Hope you are all might be waiting for the solutions. Yes, what's the first one? The coordinates of moving particle at any instant of time is given by x is equal to at square and y is equal to bt square. Then speed of the particle is, I already gave you the hint, right? So that means we are going to find the speed along x directions. How do you find it? Speed along x direction, you are going to find it out dx by dt. And along y direction it is dy by dt. So thus now our job is to find out dx by dt and dy by dt and thus find the resultant. Okay, right. And how are you going to find out the resultant here? Here though angle is not specified directly, but see along x and y directions it is given, and you know very well that x and y directions means angle here is 90 degrees. Angle here is 90 degrees. So therefore now Vx is equal to dx by dt, differentiating the given x equation with respect to t, you will get it as 2at, and vy is equal to 2bt, right? So that is dy by dt, which is 2 times bt. So now therefore the resultant speed Vr is equal to magnitude Vx square plus Vy square. So what is that? 4a square t square plus 4b square t square under root, which is equal to, if you can take 4t square common, it will become 2t a square plus b square. This is the magnitude. This is the magnitude. And what about the direction? Right? So here to find out the direction. Right? So this is along this one, it is Vx. This is Vy. Right? So two vectors. The resultant will be acting like this. That is Vr. Like we wanted to find out alpha, where tan alpha is equal to opposite side by adjacent side. If I take this as this, so Vy by Vx, magnitude of Vy by Vx. So therefore tan alpha is equal to Vy by Vx, 2bt by 2at gives you b by a. So thus alpha is equal to tan inverse of b by a. It is similar to what you have concluded in parallelogram law of vectors, is it not? Yes, when theta is equal to 90 degrees condition, special cases. Right? So in the analytical approach of vector addition, under special cases, when theta is 90 degrees, we got tan alpha is equal to b by a, or alpha is equal to tan inverse of b by a. The same is the situation here. So where b and a, there are the vectors given here. Here we are substituting vy by va, and vy by va we got it to be b by a. Okay, so pause for a moment. Try to understand what we did. Yes, now the next problem. A particle slides with a speed of 3 meter per second at point E and it reaches to Q, and the speed here is 4 meter per second, and in the process it does an angle 60 degrees at the point O. At the point O. Now our job is to find out the change in the velocity. So when you say change in the velocity, first of all, at this point tangentially, right, this is the curved path along which the particle is moving, and along the tangent at this point acts v2, that is the linear velocity. right? And here the tangent to this gives you V1. So you know V1 bar, V2 bar, their magnitudes also you know, and the angle between them is 60 degrees. Now the question is not to find out the resultant. The question is here to find out the difference. Okay, so that is change in velocity means final velocity minus initial velocity. So V2 bar minus V1 bar is the change. So therefore, modulus of V2 bar minus V1 bar is equal to root of V1 square plus V2 square minus 2V1 V2 cos theta. Yes, this is from the difference, right? Subtraction concept from analytical approach. Yes. So now V1 square, what is the velocity here given to be? 3 meter per second. So 9. 4 meter per second, 16 minus 2 into 3 into 4. 2 into 3 into 4, I am making it 12 into cos 60. Cos 60, 1 by 2 under root. So now 25 minus 12, it is 13 under root. So you have got V2 bar minus V1 bar modulus as root 13, which is change in velocity, which is magnitude of change in velocity. Okay, now how is the direction? This already we have discussed. So V1 bar, V2 bar are this. We want V2 bar minus V1 bar. So you can just simply draw V1 bar here, and this is the direction of V2 bar. V2 bar and V1 bar in opposite direction means a negative vector minus V1 bar. See, observe here. This is plus V1 bar. Thus, opposite to that is minus V1 bar. And this gives you the direction of the change in velocity. Change in velocity acts in this direction. If you want to mention it here only, just shift this, parallel shift of the vector. Here it is. This is how it is acting. Okay? Right. So, pause the video. You can note down. Yeah, the next and the last one from the numericals of analytical approach of vector addition and subtraction. Very, very simple problem, very easy problem. You might have discussed already in your classrooms also by your lecturers. Just I wanted to make it clear because there are so many methods. People will be doing in different ways of solving this. Just I want to give you like very, very quick and easy method of doing this one. So now here this depending on which one you are going to find out. See, now here the options are given. That means in terms of AD, majority of the options are given, and the other one is also AD. I think it's not O because you don't have O there. It is AD. So now if you observe the options, the answer is expected in terms of AD bar. So quite easy. Now this is AD bar. Yes, this is AD bar. So we want the answer in this term. That means remaining all additions, right? Keeping this one aside, keeping AD bar aside, remaining things we want to make it convert into AD bar. How is that possible? Right, observe carefully. And irregular hexagon, these would be the vectors. Okay, right. So now AB, BC, C, D and DE. See, if you observe, these two are equal because regular hexagon, you have the same length. All the sides will be of same length. So therefore, now observe the direction, right? This is AB and DE is of same magnitude but opposite in sign. That is opposite in direction. So I can write directly here that AB is equal to ED. Is it not? ED. ED. See, that means DE bar is equal to minus ED bar, where minus ED bar is equal to AB bar. Right? So therefore, you have this DE bar. So now if I say that AB bar is equal to minus DE bar, which is minus of minus ED bar, which is ED bar. Is it not? Very, very clear here, right? So therefore, I can directly say that AB bar is equal to minus DE bar, which is equal to ED bar. Perfect? Yes, AB bar is equal to minus ED bar, minus DE bar, which is equal to ED bar. So I got one conclusion here. So now AB bar I have, which is in terms of ED bar. And now observe BC and then this one. So exactly opposite to this one. Okay, so what is that? You have BC bar, which is equal to minus EF bar, which is equal to FE bar. Similarly, observe these two. Okay, now I'll write CD bar is equal to. Okay, CD bar is equal to minus EFA bar, which is equal to AF bar. Right, which is equal to AF bar. So now, if at all I go with, right, I have AB bar here. AB bar can be equated to ED bar. AB bar can be equated to ED bar. So this is AB bar is equal to ED bar, right? ED bar. AB bar is equal to ED bar. I am drawing it here. So now observe this. AE bar plus ED bar. AE bar plus ED bar gives you AD bar. Why am I converting everything into AD bar? Because in the options I can observe this is in AD bar. If any other thing is given to you, please take care that you have to convert the remaining all in terms of the given option value. Right? Right. Now here I want everything to be in AD bar. So therefore AE bar plus ED bar means AE bar plus AB bar. Is it not? AE bar plus ED bar. But what is ED bar is equal to AB bar. So I will write it as like AE bar plus ED bar means here this will stand for AB bar. This will stand for AB bar. AE bar plus ED bar is equal to AD bar, right? So therefore AE bar plus AB bar. So I can write AB bar plus AE bar. AB bar plus AE bar. Thus AE bar plus AB bar. Now I'll write plus AD bar as it is. And now observe the other one. AC bar and AF bar. AC bar and AF bar. But what is AF is equal to? AF is equal to CD bar. Right. Now AC bar plus CD bar is equal to AD bar. That means AC bar plus AF bar is equal to AD bar. Absolutely right. So now I will write it as AC bar plus AF bar. So these two things, because this AF bar is equal to CD bar. Right. So therefore these two will become AD bar. This is another AD bar. And now these two again is AD bar. So fantastic. It is 3 AD bar. So this is how from the picture you can just do it. Right? So when you observe it carefully, no need to write so many steps also. Directly you can feel that AD bar, right? Where AE bar plus what is given to us is AE bar plus EB bar. AE bar plus AB bar means this is what I wanted to have, ED bar. So AB bar plus ED bar is AD bar. Now AC bar plus AF bar is given. That means I need this one. Exactly these two are equal. So CD bar. So AC bar plus CD bar is AD bar. Very easy to. Like this method helps you in solving this very easily. Right? So you might have been taught, I don't know, I'm not aware. So L and L, then angle between these two vectors is theta, and then finding the resultant, right? So not in that manner, but you can do it like this very easily, just observing the diagram. Just pause a minute and then copy it down. So now today's topic, or the topic of this session, components of vectors. See, here I am going to make a comparative study between the vector components in 2 dimensions and 3 dimensions simultaneously. So it is going to be a comparative study. So pay attention. It will definitely make you get rid of all sort of confusions whatever you have till now. Really, it is going to make the concepts so clear that there will not be any confusion from now onwards. Why is it somewhat in 2 dimension and how is it in 3 dimension? So now let us see that there is a vector r bar. Okay, this is the vector r bar defined in xy plane. Okay, so now let us modulus of r bar is equal to r is the size of the vector, or rather you can say OA is the size of the vector. Now if you go for the projection of r bar on x-axis, let me name it as rx. And if theta is the angle made by r bar with x-axis, then you know very well that cos theta is equal to adjacent side by hypotenuse. So therefore the horizontal component Rx is equal to r cos theta. Rx is equal to r cos theta. Now if you project the r bar onto y-axis, what will be the size of it? It is going to be r cos 90 minus theta is the angle, is it not? R cos 90 minus theta. If theta is here given, it is r cos 90 minus theta. What is r cos 90 minus theta? Is sin theta, r sin theta. So you have the value of this r bar. That means the magnitude of this particular vector along x direction is r cos theta. And along y direction it is r sin theta. This is called resolving the vector into the components, and these components are called rectangular components of the given vector. Rectangular components of the given vector. So you can easily understand. Now we can say that what could be the coordinates? R cos theta comma r sin theta. Right? So those two are the coordinates, is it not? X comma y. What is the projection of that? The line joining on to x-axis is x, onto y-axis is y. Right? So now the projection is r cos theta here along x direction. So therefore I can take it as x coordinate as r cos theta, y coordinate as r sin theta. So these are the rectangular components, and you can write as r bar is resolved as r bar is equal to rx bar plus ry bar. That means if you are going to take the vector values along x and y directions, you are writing it as rx bar, ry bar. Let us see how to make them rx bar and ry bar. Okay, so before that, let's move on to 3-dimensional. Right, so if you are defining a vector in a 3-dimensional space, right? So that is a bar. Here we are defining a bar. Projection of a bar onto x-axis is ax. Projection of a bar onto y-axis is ay. And projection of a bar onto z is az. Right. So that means A bar has got values, different values in different directions. Along x direction, its value is x. Along y direction, it has ay. Along z direction, az. That means yet every point on this vector, this is having these particular representations along x, y, and z. Okay, suppose if A bar is making alpha with x axis, beta with y axis, and gamma with z axis. Obviously, x is A cos alpha. You can see that one. It's the horizontal side, or what we say is adjacent side. To A bar, this is adjacent side. To A bar, this is adjacent side. So therefore, AX is A cos alpha, AY is A cos beta, AZ is A cos gamma. And of course, from here only you will be listening direction cosines. Cos alpha is equal to AX by A. Cos beta is equal to AY by A. Cos gamma is equal to AZ by A. Can you understand from where and how you got it? Just from the trigonometric ratios you can directly find it out, right? So now you can write these as L, M, N. So where L, M, N are the direction cosines of the given vector, right? And you can write L square plus M square plus N square is equal to 1. This you will be able to understand, or you will be able to derive this from the concept of unit vectors. We'll come to that one, and as well as the magnitude of the resultant, right? So now here you have AX, AY, Z. So now how do we write A bar as? A bar is resolved into AX bar plus AY bar plus AZ bar. Now here what you have, these are all scalars. These are all only magnitudes. But I am writing it as AX bar plus AY bar plus AZ. That means definitely this should be having a direction. So now guess in which direction you have it? In x direction. AY you have it in y direction. AZ you have it in z direction. So how to impart direction to these values so that on adding all these vector components you are going to get A bar. Okay, so right now though you have to remember A bar is equal to AX bar plus AY bar plus AZ bar, where AX bar is the vector component along x direction, AY bar is the vector component along y direction, and the remaining one is along z direction. Right, to understand this one, just to this magnitude you are multiplying an unit vector in the direction of x. That we call it to be I cap. So what is an unit vector? So unit vector in common, you will be writing it as like any direction. Suppose Rx direction, that means in the direction of x bar. What is the unit vector regarding this? So therefore I'll write it as Rx cap, which is Rx bar by Rx. And it is in which direction in this particular case? X direction, that is I cap, this is J cap here. So I can write Rx is equal to Rx bar is equal to Rx into I cap. Ry bar is equal to Ry into J cap. Thus you will be writing R bar as Rx I cap plus Ry J cap. So Rx I cap together is Rx bar. Ry J cap together is Ry bar. Right, similar concept here. So Ax bar can be written as Ax into I cap, which is the unit vector along x-axis. Ay bar is Ay into J cap, which is unit vector along y-axis, and K cap is the unit vector along z-axis. So therefore az bar is equal to az into k cap. Thus how can you write now? A bar is equal to ax I cap plus ay j cap plus az k cap. Now this is ax bar, this is ay bar, this is az bar. So thus a bar is resolved into ax bar plus ay bar plus az bar along x, y and z axis, having the magnitudes ax, ay, az respectively. Clear? So pause for a minute and observe, and direction cosines is also done now. So now you have ax square plus ay square. So L square plus m square plus 1. So that is cos square alpha plus cos square beta plus cos square gamma. So what is it? So let me write it here. Cos square alpha plus cos square beta plus cos square gamma. What is that is equal to? I'll take a square LCM. Ax square plus ay square plus az square by a square. Right? And where modulus of a is ax square plus ay square plus az square. That is what you will be learning from three-dimensional analysis. So therefore this is equal to 1. Right. So pause for a moment. You can write down. So now the next one is position vector. Same. Whatever you have studied as components of the vector, this and this are same. The only difference here is that you are provided with coordinate points here. Now in the previous case, when I said it is components, so what is provided here? Theta is provided here. So when theta is given to you, you are resolving it into r cos theta and r cos of 90 minus theta, which is r sin theta. Right? And here you are provided with coordinate points. X comma y are the coordinates of this vector. Like where the initial point is at 0, 0, that is at origin, and the terminal or the final point is at x, y. That means you are defining the position of this point with respect to origin. That means you are defining this vector with respect to origin. That is why we call it as position vector. How is the vector like located, like with respect to 0, 0. Right now x, y. Now already in resolving, you have seen a bar can be written as ax bar plus ay bar. We have seen again I cap is the unit vector along x, ax I cap plus ay j cap. Now what are ax and ay? Those are x, y, is it not? So the projection of this a bar onto this, we are saying it as if it is ax. What is ax? From mathematics, from coordinate geometry, where is this point? This is the point at a distance of x from y-axis. That means this is the size of this side. This is the size of this side. What is that? X. So in place of ax, you are getting ax. In a similar manner, you will be getting ay is equal to y. So therefore, it is yj cap. Hence, a bar is equal to xi cap plus yj cap. Only thing is, it is something like putting the same liquid into some other bottle. So only the bottle is changed here. Concept is the same. Right? Even in previous case, we have seen here that when it is theta, you have found the values of this particular projection, that is r cos theta, r sin theta, and I said already that these could be the coordinates of the given point. Now here the thing is, in this bottle coordinates are given. That's all, concept is the same, xi cap plus yj cap. And now what is the magnitude of a bar? What is the magnitude of this hypotenuse? X square plus y square under root. So that is what you are going to write it here as modulus of a bar is equal to root of x square plus y square. And now the real concept of unit vector comes. Now suppose I know the magnitude. I don't know the vector here. How can I find out the vector here? So that means you are going to multiply unit vector to the given magnitude. Why? Why? Because that converts the given scalar into a vector. That converts the given magnitude into a vector. Right? Just that means you are imparting direction to this value. You are imparting direction to this value. So therefore, thus it becomes a vector. Now a bar is equal to unit vector multiplied with magnitude gives you the vector. So unit vector is equal to a bar by modulus of a bar. This is very commonly you will be seeing that everywhere. Xi cap plus yj cap is a bar. Is it not? What is your a bar? Xi cap plus yj cap. That one now here a bar by mod of a bar is root of x square plus y square. This is in 2 dimensions. This is in 2 dimensions. Now let us see that in 3 dimensions. Right? So the coordinate points are x comma y comma z. And we are finding the position of this vector with respect to origin. Please remember this. With respect to origin. So therefore, similarly, I am directly writing now. A bar is xi plus yj plus zk. Finished. X, y, z are the coordinates of terminal point of a bar. Right. Now what is modulus of it? Root of x square plus y square plus z square. That is coefficient of square of the coefficient of I plus square of the coefficient of j plus square of the coefficient of z. Now unit vector in this direction. If I want unit vector in this direction, right, then that is a cap is equal to a bar by modulus of a bar. You know why we are using cap? It is because cap shows that it is a unit vector, representation of unit vector. So just pause and then note down. Now we are going with the displacement vector. Yes. Now here, in the previous case, we have seen the position of the given vector with respect to origin. Now if I say that I want the position of the given vector with respect to another point other than origin. So like suppose if I want AB bar, right, I want AB bar. That means the position of this vector with respect to A. This is one way of understanding this one. Other way is very easiest way. The second one now I am telling. Suppose a particle started at A in xy plane and it moved to B, where the location at A is x1 comma y1 and the final location is x2 comma y2. What is the displacement made by the particle? This is the question. And this, of course, is the concept also. Right? So now when I say that from here to here it traveled, right? So that means it is something like B bar minus A bar. Right? So that is final position minus initial position. What is the final position vector? Whenever you say position vector without mentioning, it means with respect to the origin. Now what is the position of this with respect to origin? Let it be B bar. What is the position of this with respect to origin? A bar. Final position minus initial position is displacement. Ho gaya. Finished. So now AB bar can also be represented as delta R bar, displacement vector, which is B bar minus A bar. What is B bar? Now what is the position vector of this? You know very well. X comma Y is xi plus yj. Now it is x2i plus y2j. So x2i plus y2j. Now A bar x1i plus y1j. Now subtraction. Now you can take I common here, x2 minus x1 into I cap plus y2 minus y1 into j cap. So I got the position vector, right? AB bar with respect to point A, with respect to point A. I can say like that also. Right, so therefore now what is AB bar? That is the displacement vector in 2 dimension is x2 minus x1 into I cap plus y2 minus y1 into j cap. Extending the same concept in 3 dimensions. What is the difference? You will have one more coordinate point x1, y1, z1, x2, y2, z2 in x, y, z coordinate system from point A to point B, a particle shifted. Displacement is final position minus initial position. Whenever I say position vector, position in the sense with respect to the origin. Right, so therefore, what is the position vector? xi, yj, zk, because k is the unit vector along z axis. So the same thing, x2y plus y2j plus z2k. z2k minus the initial position. Right, done. So this is a position vector. Now unit vector, you know the magnitude. How to find out the magnitude? Square of the coefficient of I plus square of the coefficient of j under root. And here square of the coefficient of I plus square of the coefficient of j plus square of the coefficient of k. Right. So this is how you can find out the unit vector in case of displacement vector, or rather whenever you find in problems position vector or define a vector with respect to another point other than origin. See the last topic of today, triangular and Lamy's theorem. See, in triangular already we have seen the triangle and then we have converted that into parallelogram also. So there is a vector from this to this point again here. So let me name it as OAB. So O to A to B, what is the resultant? O to B. So you can write R bar is equal to A bar plus B bar, or rather you can write B bar is equal to R bar minus A bar. So there is something which is a non-zero resultant existing in this case. Right, so if that is the case, how are we going to state triangular? We say that if the two vectors represent the two sides of the triangle taken in order, then the resultant is represented by the third side taken in reverse order. What is important here? Reverse order. What is the order? O to A to B. Now what is the reverse order? O to B. What should be the order? OA, AB, BO should be the order. But here the resultant is in reverse order. Now here, Lamy's theorem helps us in solving the problems where the resultant is 0. Here the resultant is 0. See, starting from this point A, B and again reaching to the same point. That means it is a null vector, bold 0. Null vector. So A bar plus B bar plus C bar is equal to 0 bar, or what we call as a bold 0. So in this particular case, Lamy's theorem is going to help us. So what is happening here? These two are taken in order. Of course, third one is also in order. So reverse is disappearing from here. In reverse order, in case of the normal triangular, is missing in case of the special case of triangular where the resultant is 0. Paka. So now, if this is converted into this one, now suppose this is A bar, B bar, C bar, resultant is 0. Now let us suppose that the angle which is opposite to A bar of this triangle I am taking, not with vectors, is 1. Opposite to B is 2, opposite to C is 3. Now you see, what is the angle between A bar and B bar? This is not the angle between A bar